Today we're going to talk about exploring linear functions. We've been talking about what is a function, types of functions, linear versus nonlinear. Today we're going to go a little bit more into linear functions, and in the next unit we're really going to be focusing on linear functions. Okay, so in a linear function, in the last section, we said that a linear function is going to form a straight line whose rate of change is constant. That means you're always adding or subtracting the same thing. And we referred to this as our slope, and that's a key word that you're going to be hearing a lot. We also said that it is going to be in the form of y equals mx plus b. This is called the slope-intercept form of the equation. It's a very important equation that we're going to use very often. The other form you might see is ax plus by equals c. But right now we're going to focus on the slope-intercept form. So now we're going to explore different aspects of a linear function and how they relate and affect the function as a whole. In our first example, the independent variable, we're going to find the independent variable, the dependent variable, the initial value, and the rate of change for each of these examples. So in our first example, the number of grapes, G, depends on the number of branches, B, off the main vine, and is represented by this equation. So G is equal to 100B plus 4. What is coming first in this equation? So what's the input and what do I start with in order to find the independent variable? Well, the branches have to come before the grapes. So the branches are going to be the independent variable. And that is represented with the variable B. From there, we're going to find the dependent variable. The dependent variable is what came second, what comes next. In this case, that would be the grapes. The grapes are going to come second. And so that would represent the G. So the initial value is, what is the starting value? What is the intercept? Where am I going to begin? And we're going to find that in the equation at this very end piece. What am I adding or subtracting? So here you're always looking for what you're adding or subtracting. And in this case, it would be 4. This 4 is representing 4 grapes to start with. So there might be 4 grapes coming off of that main vine. But you're going to have those before any other grapes appear. And the rate of change is what is happening, what is changing each time. And this you're going to find wherever you are seeing multiplication or division. Okay, so I have the 100. The 100 is representing that for every 100 grapes come off of one branch. And we're going to save this extra box to the very end. Okay, in our next example, we have a dairy farmer can produce 25 gallons of milk, G, from 3 cows, C. So what's happening first? Which comes first, the cow or the milk? In this case, I have to have the cow in order to produce the milk. So the C for cow is going to be your independent variable, and that makes the milk being your dependent variable. What's your output? And I use G. What's the starting value? Well, does it tell me in the problem that I'm starting with any milk to begin with? It doesn't. So 0 is going to be our starting value. We have no milk to begin with. And the rate of change, how am I changing each time? What's happening? So for every 25 gallons come from 3 cows. So 25 over 3 is what I would use as my rate of change or my slope. Again, we're going to use this last box to form the equation in the end. Okay, in this last example, I have a word problem with a table with it. The cost C for joining a gym includes a startup fee plus dues every month. So what's being measured? The cost and the month. Well, I have to spend time at the gym or having a membership in order to pay money. So the month is my independent variable, making the cost of C my dependent variable. The initial value, what is the starting value? Well, looking at your table, at 0 months, I spent $20. So you're looking at that 0 coordinate. 0 months, I spent $20, meaning 20 is my starting value. Just for walking in the door, I have to pay initially $20. And a lot of places have a joining fee like that. Okay, the rate of change. What's happening each time? How is it changing each time? We were looking at tables in the last chapter, and we were seeing that they were increasing each time. So over here on the months, it's increasing by 1. This is going to become your denominator, and this will become your numerator. So over here, it's increasing at a constant rate of 10 every time. It's always increasing by 10. So we're going to put $10 over 1 month. So 10 becomes your rate of change. Okay, so now we're going to start building this slope-intercept form of the equation. We're going to look at how that is all put together. The input we know as another name for it as being the independent variable. This is represented by the variable x in my equation. The output is also known as the dependent variable. And that is always going to be represented by y. So these are what we're familiar with, the independent, the dependent, x and y. We are already familiar with those. Okay, so the new pieces are the initial value. This is also known as the y-intercept. Where is it going to intercept the y-axis if you're looking at a graph? And this is going to be represented by the variable b. And the rate of change, yesterday we talked about that this is also called the slope, and that is represented by the variable m. So let's label everything in our equation down here. We had y as being the dependent variable. We have m as the slope. X is our independent. And b is our y-intercept. Okay, so now we're going to take this equation and we're going to go back to the first 3 problems that we had and form our equations. So just to refer back, I'm going to rewrite y equals mx plus b so we can see everything here. We said y is our x, dependent is our, independent is our x. Dependent is our y. The initial value is our slope-intercept, and that's the b, and the rate of change is the m. So you're going to take each one of these and plug them in where you would see that. You can use y and x. Sometimes they're going to use different variables here, but it does not matter to me which one you use. So starting with y. So they use g equals 100. X stands for b. And the b is going to stand for 4. So this would be their equation, g equals 100b plus 4. And if you look up here, that's exactly what they had. Let's apply this to the next one. Okay, we're going to use the equation y equals mx plus b again. And we're going to match it with everything in our chart to form the new equation. The independent variable is your x. The dependent is your y. Your initial is your b. And your rate of change is your m. Okay, so plug it all in. Your y is g. M is 25 over 3. X is going to be c in this problem. And b is 0. Now, you don't have to have that 0 at the end, but you can write it just to show that you do have the initial value. Okay, last one. The independent variable is your x. Dependent is your y, initial your b, and your rate of change your m. Put all that together to form your equation. Y equals mx plus b. Y is c. M is 10. X is m. And b is 20. Okay, so now what you're going to do is you're going to take 3 sample problems. The first one we're going to work together. The second one you're going to work with your group. And the third one you're going to do on your own. The first one, a 2.5-foot rocket distance traveled in meters based on time in seconds is modeled by the following function, d equals 5t plus 2. Okay, so I have copied the equation down at the bottom so that we can see where everything goes. In this equation, we have d equals 5t plus 2. D is in the same place as the y, so that makes it the dependent. So that'll be d is for dependent. The m, the rate of change, that's in the same place as the 5. Remember, that's what's being multiplied. The t is in the same place as the x, or the independent variable. And your initial value is what's being added. That is your 2. So your contextual description of rate of change. So what's happening? In this problem, we're shooting a rocket off into the sky. So when the rocket is going into the air, how fast is it going? Well, it's going at a speed of 5 meters per second. Okay, and we get that from the meters and the seconds. The initial value is, where did it start? Well, the rocket's not lying flat on the ground. It's probably standing straight up, probably on some kind of stilt or something. So it's starting at a feet of 2, or meters of 2. Okay, so that one we did together. Then the second one I want you to do with your group. And then you're going to come back and play the video again, and you will see the answers to check your answers together. Okay, here are the answers for this problem. We have 0.5 as our rate of change, 2 as our initial value. Our independent variable is miles for m. Our dependent is c for cost. And there's your equation. Now, if you have either equation, that's acceptable for me. I do not care if you use the y and the x or different variables. For the contextual description of the rate of change, well, every mile I'm spending an additional 50 cents. The initial value means just for getting in the car, just for getting in the taxi, I'm going to pay $2. And there you go. And the last problem. Okay, this one I would like you to do on your own. Read the problem, fill in each of the answers and the contextual description. Play the video when you're ready. Okay, on this one you get $2.25 for the rate of change. You get that for every hot dog sold. The initial value, in this one, it is a negative value, and that is because you are actually spending money. So if I'm spending money, then I'm not making a profit. So that would be minus 105. Your independent value variable is S for how many you're selling, and that determines your profit for P being your dependent variable. You can have this equation here, or you can have Y equals $2.25 X minus 105. Rate of change. You're getting $2.25 for every hot dog. And the contextual description of the initial value is that you are spending $105 in the beginning just to get your materials, etc. Okay, so tonight for homework, we're going to be doing the same process. Look over your notes if you have any questions. Feel free to remind me over Remind 101 if you have any questions, or come see me on Monday morning. Have a great day.